So next here then we're just going to have a look at our advantages and disadvantages of hard water. So advantages, obviously calcium for both teeth and bones, nicer taste, and it's good for brewing and tanning. Okay, so brewing is the process of aling, okay, making ales. Disadvantages then of hard water. Obviously we've looked at our particularly temporary hardness, that it leaves limescale on kettles and boilers. And again, we've looked at the second one there where it wastes soap. So obviously all of my calcium and magnesium ions have to be used up before it will actually form a lather. And along with that, it produces scum. There's 3 ways in which I can remove hardness. The first way is through distillation. The second is through washing soda, which is hydrated sodium carbonate. We'd have looked at hydrated sodium carbonate when we did chapter 13, volumetric analysis of acids and bases. Okay, your percentage water of crystallization. And thirdly then, ion exchange resin. So in distillation, again, we've looked at this in our junior cycle. We also looked at a bit of it when we did steam distillation. So we boil our water, we have it connected to our Liebig condenser, and all my dissolved solids are all going to remain in my pear-shaped flask, and I'm going to end up with my water as distilled. This is the cleanest type of water, distilled water, that we have. However, big disadvantage here is that it's very expensive, so it's not commercially viable, so you just wouldn't really probably make enough money on this. Washing soda then provides carbonate ions. So remember, we've looked at calcium carbonate, which is my limestone, but this time we're using sodium carbonate. So my sodium carbonate, my carbonate is CO3 2-. So it's going to react here with my Ca2+, and it's going to form my insoluble calcium carbonate. A lot of the bath salts and bubble baths would use hydrated sodium carbonate because it allows this lather to form more easily for that exact reason, that you're taking out these calcium ions. So obviously it's going to form a lather more easily. The third way here is cation exchange, okay? And cation exchange works from replacing basically ions that cause hardness, magnesium or calcium, with ions which do not. For example, Na or sodium ions. So what you do is you have your water sample flowing through the resin. Inside this resin here, I have my Na+ ions, okay? And what happens is that my calcium ions are going to remain inside the resin here, and my sodium Na+ ions are going to be what's used or comes out. So because this sodium comes out, remember sodium ions do not cause hardness, it's only calcium and magnesium ions. So I've removed my hardness. Obviously with this, eventually all my calcium ions are going to remain in the resin here. So my resin will eventually lose all the Na+ ions. And how I replace that is that I just pass through a concentrated brine solution, NaCl. This isn't the first time we've seen brine either. We used concentrated, well, a saturated brine solution when we made our soap. Our soap precipitates out. So that same solution, NaCl, can be passed through the resin here, and the Na+ is going to replace my Ca2+. So again here then, I have softened my water.